Okay, so we're going to shift gears a little bit. We're going to go from talking about policy and regulation to how self-driving cars can talk to each other and to things and to us. And to get into this conversation, I want to start by introducing Chris Armstrong, who is the VP of V2X, which is Vehicle to Everything Connections at Panasonic. We have Steve Vozar, who is the Chief Technology Officer at May Mobility. Ashu Rege is the SVP of Software Engineering at Zoox. Jamie Carlson leads autonomous driving at NIO. And Hubert Verhoeven, who we heard from earlier, the SVP and GM of Automotive, Mobile, and Emerging at Western Digital. Okay, and so this time I'm going to introduce the poll earlier so we don't have to rush through that. So this time the question we're looking at is, what's the best way to handle drivers who don't want to participate in a connected car system? And I think that as the panel gets going, we can talk a little bit more about what that means. And I could only come up with 3 answers for this one. So maybe we'll see a little tighter grouping. Well, thanks all of you for being here. I want to start by talking about what the difference is between a connected car and a self-driving car. And Jamie, can you talk about what's that difference there? What are these different terms? Because I think all of this can get muddled.
Sure. So I don't think there's a dependency necessarily. We're seeing connected cars already today. We're seeing the beginning, anyways, of autonomous vehicles, and I think there's a natural tendency where autonomous vehicles will become connected or will be connected, but it's not a must-have. We all drive. I like to replace humans with the computer a lot of times when I make my analogies and even just the understanding and how we're going to design something. And we can drive just fine and we're not connected. So it's safe to think that that could happen with an autonomous car. But I think that probably everyone up here is going to agree that autonomous vehicles will be connected.
Mm-hmm. Chris, can you tell us about when you think about a connected system? First of all, let's start with what V2X really means, and what are some of the benefits that we can pull from that?
Yeah, absolutely, and it extends a little bit on what Jamie was saying. I think if you replace the driver with a computer, you're replacing the driver's ability to perceive effectively. So a driver can't see around curves, the driver doesn't know what is a mile ahead, everything like that. And so the big difference between a self-driving car and a connected car is the ability to see things that a person can't see effectively, to have another extension of a sensor or an extension of the ability to perceive. And V2X is really about the interactions between vehicles and the interactions between vehicles and that environment, the infrastructure, pedestrians, bicyclists, whatever it might be. So whether it's a localized sensor technology or whether it's an internet sensor technology, V2X allows a car to see around the curve. It allows infrastructure to share the status of a signal, the location of a construction zone, anything like that, so that our transportation system can work better for the cars and our cars can operate safely on the transportation system.
So in the near term, maybe we're talking about vehicles that can communicate maybe relatively close to one another, like hard braking 3 cars ahead, so you should start easing off the brakes. And maybe in the long term, you're talking about cars moving around like schools of fish, because we can kind of rationalize everything.
Absolutely, yeah. I sort of view transportation as a public commodity, not that different than electricity or water. When you turn on your faucet at home, you expect the water to come out. And we really want to see the transportation network operate as a system, not as a bunch of individual vehicles or individual drivers rolling around. Autonomy would be wonderful, but if it takes you 3.5 hours to sit in a car going somewhere, when it really should take 30 minutes, that's not a school of fish. That's not a transportation system working for all of you. It's a transportation system that's being used in its capacity.
Ashu, how do you think about what's the potential of connected car for what Zoox is developing, which is, God, I'm going to say it like the traditional notion of a self-driving car? Is there a lot to gain there, or is there maybe it's not ready yet?
Yeah, I think it's important, first of all, I think in this conversation, even in the previous panel, to distinguish between what people call level 2, level 3 type of autonomy, which is you are in a car with the steering wheel, and you're supposedly responsible for taking over when the car cannot quite do the thing, the performance function. Whereas what Zoox is working on is, and some of the companies represented here are also working on, is what's called level 4 or level 5 autonomy, which is no steering wheel and absolutely, therefore, no driver. And those are very different things. And connectivity to enhance the first case versus the second case is quite different. And the most important thing to me, for us here is the safety case. So you cannot create a safety case which is dependent on connectivity. If you did that, then you do not have true autonomy, because essentially then it becomes a contradiction. Because the vehicle needs to do this, be safe by itself. If you are reliant on an external source, which is, for example, things, maybe there's sensors on poles in a city, for example, and that you're communicating with that, and that's providing information. That's good to enhance the performance of the vehicle, to make it maybe more safe, but it cannot be the baseline case, because now you have a strong dependency on that particular infrastructure. And so if your safety case is dependent on that, then your failure point becomes that particular entity. And that's definitely both subject to degradation as well as actual malice, that somebody can attack that. So.
Maybe even a level below that, you're waiting on infrastructure to be built out, and as we know, infrastructure takes a very long time.
Yeah, and as we know, cities are cash-strapped, and so again, who's going to be providing that? And how does it scale? Like you're going from city to city, you're going to sort of inhibit the deployment of these technologies, because now you're dependent on the city to provide that type of infrastructure. So again, we, at Zoox, at least our philosophy is we need to build fully autonomous solutions that work on their own and are safe on their own. And it's also very important that they finish the mission. That's the other part, right? It's not enough to just have a safe system, because if you have a safe but very shy robot or vehicle, and it's going to get bullied by human drivers, and it's going to take an hour to finish a journey that typically takes 15 minutes, that's not a great solution either. Right, so you kind of have to solve both of those.
We learned. It can punish them, Bryant told us. Steve, I want to hear the perspective of May Mobility here. But first, can you give us a quick rundown of the way what I in my head call Maymo? Sorry.
Some people call it that.
Yes. Okay. Can you give us a quick rundown of the way May sees self-driving cars operating? Because I think it's a little bit different, and I think that might help inform the way you think about this technology.
Sure. So at May, we really are trying to get people to benefit from self-driving technology today. We don't want to wait for the next generation of sensors, the next generation of compute, the next generation of algorithms. So we've basically determined a business case that fits with the safety case and operational design domains in which we can operate today. And as a practical matter, that means that we lean very heavily on things that a lot of people who are shooting for a level 5, anywhere, anytime, self-driving cars won't do. One of those things is to be in a very highly geofenced area. Right now, we're only on fixed routes, but we are deployed, and we've transported over 150,000 people across 4 cities. And another thing that we do is we actually physically put up infrastructure in the world that is a part of our system. In particular, we put up cameras to help us do categorization of traffic lights. And so that is our view, is like there's no pride in doing it sort of the right way. Like, we are very practically minded, and we will do what it takes to get this technology out into the world today. And so that means sort of taking some approaches that are different that other people refuse to do. And I just want to sort of comment on what you said, which is that there's no safety case that can be made if you rely on infrastructure. And I just disagree. I mean, you could extend that to say there's no safety case to be made if you rely on infrastructure of the road. The road could fall apart, and then you're not safe. I think if you view the infrastructure as another sensor, then you have to be able to say, well, can I rely on this sensor? And for sure, like if we're saying today, can we rely on those sensors as well as you would rely on automotive grade radar today? The answer is no. But in a theoretical case, or in even a potential real future case, that sensor that's in the environment could be as reliable or more reliable as a sensor that's on board the vehicle itself. So I think I just disagree with the way you categorized it.
Yeah, let me clarify what I meant by that. What I'm saying is you're looking at either if your probabilities are going to be multiplied, in other words, your probability of failure with your existing system, and then you have an external sensor, and that's basically making your system even safer because the probability of failure is multiplying into your current system, which is fine, right? That's an additive thing. It's when you're saying you have that as your main sensor, say, or your main system, then you're now reliant on that thing, which is maybe not as much in your control because the vehicles, at least in our model of level 5, level 4 autonomy, we operate, we are both building a vehicle from the ground up, and we operate those vehicles. So we are essentially providing an autonomous mobility service in geofence areas, just like our approach is very incremental, very pragmatic, no different than what you're looking at. But we strongly believe that this way you control your destiny in a much more deterministic way, whereas when you're relying on other things externally, and we're not saying we won't not use them, but the question is we'll use them to enhance our service, not we won't be dependent on those sensors. Right. That's kind of our approach.
Well, and today I think that's what we do as well. We use it to enhance. But I think that to say that there is no way you can ever make a safety case based on...
I did not say that.
So really it's about, like, you're multiplying the failure rates, but that's
right.
because of the way that it acts today.
Correct.
If in the future it was as reliable as an onboard sensor, then
yeah. But then that becomes in the future as opposed to getting it out there sooner. So
I think it's fair to say there's no individual sensor you can rely on the car. Everything can fail, right? So you've got to have backup safety cases.
The architecture we are developing is multiply redundant across both sensor modalities as well as the different the sensors within the same modality. So there's massive redundancy that's built into our system.
Right. Hybrid, I want to back away from self-driving cars. Let's take it down to like level 0, maybe level 1. What can connected car tech do for drivers today? Like, what can it do beyond the ideas of controlling the way the car drives? Like, how can it make driving more pleasant, more whatever?
Yeah, and I think there are a number of things to look at that, right? I think there is certainly what can a connected car do to drive better, right? And that was the discussion we had earlier. I think as a user today in the car, the basic function of connectivity today is when my phone rings, I don't have to fumble for my phone if everything is connected, right? I think what we're seeing more and more is that from our perspective, the amount of data that is being created in the car, but also the data that comes into the car is growing exponentially. Whether that is going from a static map on a navigation system to a high-resolution static map on a navigation system to a connected map where there is the information from what is going on around you, right? There is construction, right? Some of that we take for granted now. But from our perspective, I think what we take for granted now as technology 5 or 10 years ago was not available, right? So as a user today, I think the nice thing about automotive is I think we're all users one way, shape, or form. I think that a lot of the technology that we see eventually go into cars. Took a long time, right? It used to be mobile phones would do something, then people say, well, why can't I have it in my car and why can't it have it be safe? What we are seeing with a lot of customers is that they come to us and say, can you have a ease of use that you can get with a handheld device, and can you have the ease of use be safe but incorporated in the vehicle? And that drives a lot of things. It drives certainly in some geographies aggressive use cases of can I watch a movie in my vehicle when it's parked? The other one is people can modify that, can I watch a movie in my vehicle as it's driving? So I think what is being put in place from our perspective right now is not just the data in the car, it's actually data coming into the car to enhance how we use the car, whether it's navigation or broader. It is also putting pressure, I think, on the car manufacturers in general of what does infotainment in general look like, right? Bring your own device, but then how is that safe? Or do you have an optimized in-car entertainment system? And we see more and more of our customers looking at, can I have the seamless experience between outside of my car and inside of my car? And that drives data, it drives connectivity, not always in a mission-critical sense, but I can guarantee you that if you are using your entertainment functions and they don't work, and you start yelling at your device, which is now voice activated, that your focus on the road is going down. I had it on my drive over this morning. And the device told me I'm doing my best. It was programmed, I guess, to respond to my yelling at the device. So I would say that the gap between the mobile devices, which you renew relatively frequently, and what you get in your vehicle, I think we all expect that gap to close rapidly, and I think it is.
Jamie, how important is it to close that gap? Coming from a company like Neo, very new, very tech forward. It's got a nice big screen in the middle of the car, and even a little digital assistant.
Yeah, so I think there's a lot actually to be learned about level 2 driver assistance systems as a method and how we're going to get a lot of this connectivity into the world.
And can you quickly define level 2, just so we know what we're talking about?
So it's things like adaptive cruise control, it's things like autopilot, emergency braking. So let's use a scenario to illustrate my point. I think we're all up here because we all agree that at some point in the future, once all cars become connected from the form of V2V, that it's extraordinarily useful to help us do all of our jobs better. But how do we do that? It's very, very expensive. The turnover rate for automotive is anywhere between 10 and 12 years, meaning if all cars start shipping today with V2V technology, and it takes at least about 10 or 12 years until the majority of cars, right? So the challenge that we face is that we're always trying to solve for the least common denominator. So if I too like the analogy of thinking of this thing as a sensor. If you think about having a sensor in the car that on day 1 can see 1% of other cars, and on a year forward from day 1, it can see 10%, and at some point it's 99%. That might enhance, is kind of the word that we're using, automated driving, but in a level 2 technology like emergency braking, that actually lends itself very well, because if at some point where I can see 50% of the vehicles, there's plenty of use cases where the modality of the sensors that are in my vehicle, whether it be camera or radar or both, may not be able to see that car in front. Well, if you give me a 50% chance that that car I'm about to hit, that I'm distracted, and my sensors can't see it due to fog or rain or snow, that might prevent or mitigate a crash. And this is the whole premise in which NHTSA works under today, and this is how technology becomes regulated and becomes mandated. So while it's more fun to talk about V2V and V2X in the context of level 4 driving, I think you need to actually begin with things that are a little less exciting, like emergency braking, to have a use case that gets the technology into the market.
But are you also saying that sensors don't have to necessarily be perfect to enhance safety, right? It's maybe an AI machine learning analogy that nothing has to be perfect, the algorithm doesn't have to be fixed, and yet you can still improve what you're doing, right?
Yes.
If we assume that everything always has to work 100%, I don't think we're going to get to the right answer.
It's exactly my point. If we had a wand and we could make every vehicle have this technology, somebody would have waved the wand by now. But we need to have a business case, because OEMs need some incentive to get this into the vehicle, V2V technology into the vehicle, and they're not going to do it on their own. And so NHTSA, as an example, needs an incentive to help influence that. And hopefully my example of how V2V can help functions like emergency braking, just to name one, I think this is how the technology ends up in your car in the future.
Chris, can you give us a real quick history lesson about the way the federal government has looked at vehicle-to-vehicle technology? Because there's a lot of talk about DSRC, right? Dedicated short-range radio communication. Yep. Is that right? Now we're seeing talk about 5G, maybe surpassing that. So can you just break that down for us? How is the government looking at this technology in the U.S.?
Quick is going to be a hard thing to do, but I will do my best. So quite some time ago, 1999, the Federal Communications Commission dedicated a specific set of spectrum to ITS, Intelligent Transportation Systems, specifically for safety in vehicles.
Spectrum.
Coveted spectrum, yeah. If you all have not looked at the radio spectrum allocations in the US, do yourself a favor and Google that, and it is a scary picture full of colors that's impossible to read. But just know, it's every single slice of that pie, gigahertz, megahertz, and beyond is very, very coveted. And this particular spectrum allocated in 1999 is 5.9 gigahertz. And for those that are familiar with RF, that's not too far off from the 5 gigahertz Wi-Fi router that's in your home, or the 2.4 gigahertz version as well. So it's in a very interesting part of the spectrum that's highly coveted, but it performs very similar and even better than Wi-Fi in your home in many ways. It's really low latency. It sees through weather really well. And it has a lot of other characteristics that make it amenable to sharing data in fast-moving environments. So we as humans need something like 0.2 seconds to respond to something, and this communication spectrum supports 10 hertz or 10 times per second very, very reliably. So back in 1999, that was dedicated, and since then, standards in the automotive community, the Society of Automotive Engineers, have been worked on to define message standards that would allow vehicles to share data back and forth, and allow vehicles to share data with infrastructure and back and forth as well. And there's been a long trajectory and a long history since then. Many naysayers in the industry say the spectrum has not been used at all. And the reality is it's not in very many cars today. It's in very few cars, so it's in some ways a fair.
Right?
And a few GM Cadillacs, yeah. And in Japan and other countries, many, many more cars. And since that Wi-Fi technology was used initially, you mentioned dedicated short-range communication, there's now a new emerging technology called cellular V2X, which uses a different standard to use the same spectrum in many ways. So Wi-Fi is channelization. It's sending packets on different channels to share information, and cellular technology time slices. So you can use that same spectrum in different ways, and there's sort of competing technologies out there in the industry today. Different benefits to each, different opportunities for
There's
each.
this new one based on 5G, is that the idea?
That's right. So cellular standards come from the world of 3GPP standards, and there's a trajectory for cellular to go towards 5G. So time slicing is aligned with cellular technologies of today, and has extensibility to future 5G technologies as well.
Right. Stephen, Asha, I want to go back to you guys. Maybe you don't want to have your car rely on exterior sensors, but is there information you could pick up? Are there benefits you could see from just knowing more about the environment?
Oh, yeah, absolutely. I mean, you could, just traffic patterns, for example. If the construction zone has just popped up in SF, for example, that happens pretty much every day. There's some street randomly shows up with the construction zone. Events, right? Or specific, like, I don't know, some kind of disaster or whatever. All of those you can then essentially use. If you imagine a fleet of these vehicles running around, they can absolutely start routing themselves appropriately away or towards a specific event. If the Warriors game or the 49ers games lets out, maybe you want to send the vehicles over there, right? And those types of things absolutely would enhance the overall sort of efficiency of the fleet as well as the general experience for the customers.
Yeah, absolutely. I think one thing to add there, I mean, 100%, but also, especially when you're thinking about automated vehicles, the ability to communicate with emergency vehicles. So not having to rely on sound and light, but really having that dedicated channel for communicating where those emergency vehicles are traveling, what their plan is, where they're going to travel, and steering clear of that altogether if possible.
At the very least, if you're on that route, having an extra bit of information, we need to pull over.
Exactly.
And if that fails, you could still hear them, detect them, that sort of thing. Hubert, how interested are cities and local governments in getting their hands on connected car tech or connected infrastructure tech?
I think the answer is probably that it depends very much, not just between the cities, but also in geographies, right, broader geographies. Certainly, when we talk about what is happening in China right now, there is a strong desire to move fast, I think, in many cases, in adopting new technology. But there's also certainly a very strong interest in from a public safety perspective and broader, to understand what is exactly happening in what is deemed to be a safe city, right? So I think in that case, certainly, government-driven, there is an interest, a strong interest in the new technology, but also the broader picture you get out of that, right? I would say that, and we talked earlier, I think in the previous panel, about Europe versus the US. I am not as much aware in the US of local governments having an extremely strong position on that, and I think some of the panel members here may have seen more of that than I have seen. I've certainly seen on the emerging geographies much more of a holistic view, because a lot of things are being planned at the same time, where here we have much more legacy, certainly in the infrastructure. But I'm sure that some of the panel members have a broader view on that.
Yeah, certainly at Zoox we have a lot of interest. I think if you start thinking about the benefits of this technology when fully deployed, it's just going to make cities far more livable than they are today. I mean, you look at the Bay Area, I call it the 0th world, not even first world. We have everything pretty much, except, you sit in, I mean, all of you sat on 880, 237 for me, for, hours sometimes. And that time that you can recover back and make the whole transportation system far more efficient is definitely generating a lot of interest. So we get very often visited by mayors from all over the US, even from Europe and Asia and other parts of the world. So there's absolutely strong interest, but I think it's kind of like everybody's kind of sitting around thinking, like, how is this going to come to be? So I don't know that people are actively sort of saying, hey, but we definitely have cities encouraging us, for example, to go and operate there, for example, and things like that. So
I was just going to say it's a really interesting time of disruption, not just in the automotive world with self-driving cars coming, and the need to understand and build software increasingly, right? That's a challenge in the automotive community. The same thing is very interestingly happening in the transportation community. These are primarily civil engineering organizations that are trying to figure out how the heck to interact with an increasingly connected world. And I like the term connected car, but I even more like the term connected system. And the reality is, our cars are going to have increasingly amounts of information. Our cities already have a ton of information. And if we're not all taking the responsibility to make it a better system, not just our individual thing better, but the overall thing better, then we're not doing something right. That's what I loved hearing about on the previous panel, is it is sort of intrinsically upon all of us to make sure that the end result of what we're trying to do is better. And if we're not leveraging the assets and the things that are already out there, then we're not doing a good job. And so these civil engineering organizations are out there trying to figure out how to better become data companies in themselves. And they have a lot of information that available that can be shared, can be utilized, but instead is being recreated somewhere else or perceived somewhere else. And I think it's kind of intrinsic on all of us to see these two industries come together and work together better in that fashion.
And are we also talking, when we talk about V to X, right? V to everything. That's vehicle that talks to other vehicles, that talks to infrastructure. But are we also talking about like pedestrians and cyclists? Like it can figure out where you are so it doesn't run you over when you cross the road?
Yeah, I think that's absolutely necessary, right? It's just bad. Transportation is bad physics, especially in dense urban areas, right? 150-pound, 250-pound human being, it is not going to compete well against a 4,000-pound machine, whether it's driven by a human or whether it's driven by a computer. And so we have to know that the physics of that environment are really bad and protect everyone accordingly. Same goes for bicycles, same goes for vulnerable road users. Everyone of that sort. So if this technology doesn't extend and help those folks too, then we're doing something wrong.
And how would that actually work? Like with your cell phone, it picks up a signal?
There's a lot of different ways to do it. There's interesting pilot projects going around. LiDAR is really helpful and interesting on the car, but it's also really helpful and interesting on the intersection. The car's environment is constantly changing, but that intersection is the same all the time. And so you can do interesting things with static environments, and you can do interesting things with sensors like LiDAR to understand where people are and why. And even if they can't communicate themselves, verbally, physically, even with their phone, the intersection can communicate on their behalf and tell the car where they are or something of that sort.
Steve, you talked about using cameras to monitor traffic lights. Is that right? Are you interested in doing the kind of thing that Chris just described?
Yes, that's another use case that we are interested in and working on, particularly for sort of tricky intersections. And I agree I think that is the right way to go. I mean, I just shudder to think of how inequitable it is that if you don't have a cell phone equipped with 5G, that you are now more vulnerable to self-driving cars. I mean, that's a horrible thought. And so I think that if we're going to make V to X, interact with vulnerable road users, it should really be the onus of whoever's putting up that infrastructure to be able to detect all road users, whether or not they have a piece of technology in their pocket. But certainly we are looking at it from the safety case, and also honestly from a bill of materials case. We think that we can reduce the cost of all of the sensors on the vehicle, reduce the set of sensors we have if we can put infrastructure at strategic locations around the areas in which we operate, so you're not decking out your car for those 5% of cases where you need to see across 6 lanes, but rather getting that information from the sensors in the environment.
Especially, and you can do that because you know where your car is going to be operating.
Exactly.
So you put it out there.
Exactly.
We've got about 10 minutes left. I'd love to open it up to some Q&A from the audience. So yeah, I think we've got a question down here. We can get you a microphone.
Hey, really great knowing about how these cars would work, because I don't know anything about tech, so coming from a completely layman. As these vehicles talk to each other, what kind of regulations or what kind of practices would be implemented that they don't feed off bias of any kind when they are in that situation, when there's a car crash or any kind of road rage happening?
The question is about bias.
Yeah.
So interestingly, I mean, I'll say that the standards are more about information transfer than what you do with that information. So I'm not going to say that there's no bias, but actually there's less risk of bias in what is being transmitted. It's more sort of factual information about speeds and locations than things that could be interpreted. It's sort of up to the company who's using it to interpret it in a certain way.
But I think certainly your point of bias, there's a lot of publicity certainly on consumer devices, right, where there's machine learning and they say it is excluding genders, races, right? And that is, as was said, it's much more the processing of that information. The information is raw and probably scientifically objective. What happens certainly with that information in a vehicle, there the questions could come into play, right? And I think there is a heightened awareness right now because a lot of systems are trained with a certain number of test cases. And if those test cases don't represent a cross-section of what you want to test for, you will have bias even though it is a computer system, right? So I think that awareness is driven today in a lot of consumer, highly visible applications. My expectation and hope is that certainly on these systems in vehicles that people have learned from the need for complete test cases, not just for safety, but also to address things like bias.
So the ownership is actually on the people who are actually creating it. So that's really great.
I think it will have to be. You can always say it's legislated, but then you get back to the question of what are the test cases you use and are they diverse enough to not have that happening.
Thank you.
Hi, it's very good to get to know about having a connected system, but I have a question regarding how does the system supposed to handle renegades? For instance, let's say there's a car signaling the car around, saying I'm going to change lane to the left in 3 seconds, but what actually happens is the car doesn't change, and it certainly can disrupt the system. And the data is actually valid. It's not like a corrupted data, but it's, with bad intention. So how does a connected system, connected cars, be able to handle cases like this?
Are there fears of renegades? I think turn signals, I know everyone I've ever talked to working on autonomous vehicles has told me that just like a good human driver, they don't put too much faith in people knowing when to turn on or turn off their turn signals. But I guess how do you think about, is the term renegade, Ashu or Jamie, something you've thought of? How do you predict maybe not bad actors, but random actors?
Yeah, absolutely. And you have to, if you think about how you want to solve this problem in general and decompose it into sort of the pieces that are solvable. And so you have to have a baseline safety system, which is something is in front of you and you need to be able to come to an emergency stop, right? Because if you're too close or whatever. That you have to have an architecture that has that built in, right? And for humans, it is we react and we slap on the brakes. Hopefully, we can design through the intelligence of the autonomous system something far better than that. So if somebody does act in an unpredictable, random manner, there is that sort of safety net system. Then on top of that, you use all of these information, like turn signals, as priors to make your performance better, which is that you drive more smoothly, you anticipate things better, and that's what's great about autonomous systems. They don't get tired. The vehicle, for example, we are designing is full 360-degree view. So when it comes to things like bicyclists, what's cool about even today our level 3 systems that we drive in San Francisco, they see stuff that when I'm in the vehicle, I go, well, what's it doing this for? And then you say, oh, there's a bicyclist coming right, in our blind spot. But our vehicle doesn't have a blind spot. So there are all these other things that you can use to enhance your driving performance, but you still need to have a baseline safety system, and that's how you make sure that you can handle all those corner cases of random things that'll happen.
I do share your concern a little bit in that the first test cases of that with bicyclists in Amsterdam, it's not necessarily about one random actor. I think you have a couple 100,000 around you, right? So I think the earlier question of completing the mission with a lot of chaos around you, whether that's in Bangalore or in Amsterdam, I think that there are interesting test cases certainly where I would assume that system performance is impacted by a large group of fairly randomly acting people. Is that a fair?
I don't know. I mean, our system actually does pretty well. If you go to our Twitter feed, for example, we post regularly how we handle very large crowds. For example, we started driving in Vegas earlier this year, and we are driving at night there when shows let out, and it's literally just a swarm of people. And so, I mean, that's why we have to design for those cases. I mean, you cannot, like I said, we call them the Zooks laws of robotics. The first law is do no harm, which is the safety system, essentially. The second law is finish the mission, though, because you don't have a product. If your vehicle is going to just sit there and get stuck, and even if it's happened once every so many times, you have thousands of these running around now, and that's happening almost to 2 or 3 passengers a day. You don't have a great product. People are going to stop using it. And the third law is make the experience great, right? If you're driving in a very sort of jerky fashion, or you're making the customer feel unsafe for whatever reason, that's not a great product either. So that's all three we have to solve for, and that's what we are looking to do. Yeah.
I want to quickly add something to what Ashu said. So I think there's actually some parallels that we should draw with V2X, and actually even the last panel on regulation. Anytime that you're putting in any kind of infrastructure that your own vehicle or own automated system is going to rely on, I think that's when standardization and regulation actually becomes very important. Ashu touched on this earlier. I'll trust something else if I know that I can trust something else. And I think the parallel I want to draw here is these systems have actually existed for a long time in aerospace. Transponders and ADS-B has been something that's been around for I don't know how many years. That if you're not familiar with what I'm talking about, this is how the tower knows where your airplane is in space. It's because of a transponder system. It interrogates your plane and it responds back with your tail number and your airspeed and GPS local coordinates and everything else. You know, it's a fairly archaic version of what we're up here to talk about today. And the difference is tower tells you go to this altitude, up or down, because there may be another plane that you want to avoid. You know, I think it's actually we tend to avoid looking at aerospace because it's slow and old and clunky, but really we're just kind of redoing a lot of the same thing in a much more complex environment. So
in 2D instead of 3D.
Yeah. a lot more to hit on Earth than there is in space. So
I think we've got time for one more question. Yeah, right here.
Yeah, how do you see divergence of different geographies in terms of V2X? And so I'm talking about divergence and what you're observing in Europe, what are you observing in US and Asian countries? Do you see some regions embracing V2X and others being cash-strapped and cannot even handle homeless people on the street? Are they going to invest in V2X heavily?
Chris, do you want to?
Yeah, absolutely. So it's been interesting to see how this has evolved over time, because the worldwide effort started around the same time that the FCC had the foresight to dedicate spectrum on this in 1999. You can imagine different countries, different continents act differently in this way. But what's interesting is to see what motivated the rollout of the technology. Japan is a really interesting example. If you've driven around Japan or traveled around Japan, they used V2X technology primarily for tolling initially. And so it was a revenue generating and transportation funding mechanism that scaled the technology broadly across the country. And when they had that technology in place, they can now use the data to implement safety and mobility applications as well. So they can do congestion pricing. They can do speed harmonization with the use of the technology, understand current speeds. They can do all sorts of stuff. In the US, there was a similar opportunity to use 5.9 gigahertz technology for tolling, but there was an effort to go a different direction. And now we've tried to implement the technology with safety and mobility as the primary motivation, and it just hasn't been able to achieve market penetration in the same light. Tolling could come later if you did it that way, but the motivation is really important. important. Europe is very similar to the US. It's not used for tolling. It's primarily used for safety and mobility, and market penetration has been low. So that's not to say Japan is right. It's a much more homogeneous government society there, so it's easier to implement things at scale. But the motivation has to be right, and we have to implement it at scale in order for it to be effective. Autonomous systems won't depend on it. Cities won't run more smoothly unless it will be implemented at scale. Safety and mobility is a good motivation, but it's got to be adopted and embraced by people before it can be implemented.
So I think we're just about out of time. I did want to quickly review our poll question here, where I wanted to know what's the best way to handle drivers who don't want to participate in a connected system. I'm sure that once we talk about drivers doing things like speed regulation, you know, in American society, there's that independent streak. There are going to be people who are, I think, justifiably worried about privacy concerns, and so I just wanted to see how people felt about, like, what do you do with those people? I guess I didn't really know what to expect in the answers. Does anyone have a reaction to this? Which one of these seems
more harshly?
Right. I guess which one of these seems the most likely?
I think all of us would agree we prefer B, but I think the likely candidate is A. You know, the way that the automotive industry already works today is there's, I don't know, the first thing that comes to mind is emission laws. You know, this is constantly increasing and getting more and more difficult, but the Department of Transportation doesn't say you can't drive that 1950 Chevy on the road, and I don't see them changing course for something like connected cars.
But they certainly don't allow horse and buggies on highways now.
Fair point.
So I think it goes back to what you said about the 10-year window type of thing, where I think A will be the sort of the predominant thing, obviously by definition, but then it'll certainly dial over to B at some point, and certain roads, highways, whatever, will stop, you know, allowing cars that don't have, you know, you'll have some kind of toll or whatever thing that checks.
So dedicated lanes.
Yeah, there are dedicated lanes, for example. And I think that's how it's incrementally going to get dialed more and more towards. And ultimately, you know, at some point, I don't know, you won't be allowed to have a non-autonomous vehicle, I suspect. But
the person in this chair tends to talk about trains, right? If you look at how train networks develop differently in Europe versus here versus Japan, at some point, if you want to have a true high-speed train network, you will have to separate it from your cargo trains, right? And certainly in the US, I think that has not happened for a variety of reasons. People not being used to traveling on high-speed trains. But being one of them, Japan took the complete opposite direction, right? So I think we will get to the point that if people want all the benefits of the school of fish moving faster, you will have to have near 100% of those vehicles, or 100% of those vehicles at some point probably behave in a similar way.
Steve, closing words?
Yeah, I think, you know, C is actually probably more likely than I think we're giving it credit for, particularly with respect to what we talked about in the last panel, insurance. I think that could really drive this. So it's more maybe a more neutered version of C, right? But your premiums could definitely go up if you don't have this technology. If you, just like when you drive a red car, your insurance goes up because you're less, or you get a discount if you have it. So I think, you know, it's similar, but maybe not exactly the same as C. But I think honestly that will drive a lot of this technology as well.
So this panel ends with more insurance costs. With that, I just want to thank everyone for joining you. Thank all of you for coming out tonight.